In this video, we're going to go over a scanned concrete asset that I worked on. There's quite a few projection errors when I was doing the 3D reconstruction, just due to lack of coverage. So what we're going to do is put this into Unity ArtEngine and do what we can inside of there to clean it up and also make it a fully tileable material. Okay, so here's the 3D reconstruction that we're going to be working with today. So right away, you'll notice that there's this area over here that's missing a lot of data. Now, if you've done photogrammetry for quite some time, you probably won't run into this issue, but if you're new and you're just learning, these mistakes are bound to happen. And also, if you turn off the textures, if we kind of look over the mesh, you're going to get these areas also where there's low detail and there's high detail as well. I'm not really entirely sure what kind of happened with this capture, but I was shooting with a new lens and I wasn't really used to the narrow capture size that I was getting from my camera. But in any case, we have this thing all baked out and ready to put into ArtEngine. So we're just going to jump over there and see what we can do with it. All right, so we're just going to go and drag and drop our baked data set. So the first thing I'm going to do is I'm going to look at the albedo map. You'll notice that there's kind of a slight gradation in the lighting for this. So I'm going to use a gradient removal and quickly just equalize everything out. So be careful with the gradient removal. It does tend to wash things out if you use it a little bit too much. So the first part of my workflow here is I'm just going to really quickly put a seam removal and just see how it works. So just for your information, this is sped up 1.5 times. So overall the process took about 30 minutes in real time, a little bit less than that. So I'm just going to run the default seam removal, change the viewport to a plane, and tiled it 2 by 2. That way we can just check the seam area and see how it does. So for a pattern like this, it's going to be quite difficult just using the seam removal node. So you'll see that we have a more complex pattern to work with here. And initially it actually looks not too bad, except that you start getting these kind of weird fusing of shapes along the seam borders. That's because the AI is trying to piece it back together. So for something like this, what we're going to do is actually use something called a structure guide. And what a structure guide is essentially is a black and white map that's going to guide the AI to reassemble it in kind of more of a smart way, essentially. So what I'm going to do here, instead of drawing the guide by hand, I'm going to use the ambient occlusion map, and I'm just going to push a high pass onto it, just kind of even things out a little bit, add a little more contrast. And then I'm going to use a histogram scan just to see if I can bump up the levels a bit more. So the thing with the structure guides, they're a little bit finicky to use, to be honest. I do have a video about the structure guides. They're a little bit unpredictable, to be honest. So I found that doing this kind of high pass method seemed to work the best with this type of material. I have a video about doing some bricks as well, which is a bit more straightforward, but this one, for some reason, just due to the complexity, using the high pass on the ambient occlusion map yielded the best results, at least the way I found it. So what I'm going to do is I'm actually not going to use a seam removal. I'm going to use the mutation node, and I'm just going to test out my structure guide first by applying it to only the albedo. And the reason why I'm doing that is because the mutation node is quite heavy in terms of the computation power. So I'm not going to use the entire full 4K set. I'm just going to test it out first on the albedo map. And you'll notice that I pressed the preview mutation, and what that's going to do, it's going to do a low quality version of the mutation. And I want to use the preview mode because I want to dial in the sliders, kind of fine tune things. And if you don't use the preview node, you have to keep executing it every time you slide some of the sliders around, just because it's doing a lot of computation. So what I can do now is actually start to look at the border edges and kind of real time adjust them. And it's a lot quicker than having to re-execute the node each time. So the goal of what I'm doing here is just trying to understand what are the best settings in the mutation node for this to actually work. So each time that I'm sliding things around, it's going to really quickly compute kind of like this low res quality version. And I'm just going to go ahead and inspect it. And right now I'm playing with the feature ghosting. So when you're working with a structure guide, the feature ghosting slider is really, really useful. What that's going to do, it's going to kind of dictate the threshold of where features begin to blend together. So if you have an area where things are starting to blend a little bit too much, you can slide the feature ghosting up and down to see if you can kind of come up with something that looks more natural to the pattern that you're trying to seam remove. So I also went down to the seam borders checkbox there and kind of played around with that as well too. So, I mean, you know, if you're watching this video for the first time, there's a lot that's going on what I'm doing with the sliders. Mutation is probably the most complex nodes within ArtEngine. It's also one of the kind of the workhorse behind all the other nodes like seam removal and content aware fill. All of those are kind of like offshoots of the mutation node. So I would definitely spend some time to play around the mutation. It's definitely the most powerful node, but it does take time to understand how to use some of the sliders. So right now I'm just using the blemish healing, seeing what that comes up with, and then adjusting the feature ghosting. So every time I do these sliders and I pull back, I start to look at the shapes again, just to make sure that they're looking like cracked concrete, because, you know, cracked concrete has a really particular shape to them. And sometimes the AI, when you're doing the seam removal stuff, it's going to try to make like a new shape out of it. So what I'm doing here is I'm kind of playing with the sliders to a point that when it regenerates a new shape, it looks like cracked concrete, because the software doesn't know like what the surface is, like what I'm actually working with. But what it's going to try to do is use the structure guide that I put in there, and with some of the sliders and parameters, it's going to do its best to reassemble itself to resemble the original original source image. So there we go. So that one's looking pretty good. And again, I'm just playing with the feature ghosting. And this one I think I'm going to keep over here. So I'm looking at the edges here. There's no like weird shapes that kind of stand out. There might be like the one or two odd shape that doesn't look like cracked concrete. So you'll start to see there's still a few kind of like fused together. So, you know, we're going to do the best we can with it in that case. And so that setting I was happy with. So what I did there was I removed the single albedo input and I changed it to a full material input. And then I put my whole data set in there, and that's going to go ahead and recompute. So what I did there really, just to sum that up, is I used a single map with the structure guide, played with the settings in a really quick and iterative way. Once I was happy with that, then I plugged my full material in there just to save some time. Cool. So we're going to take a look at it again with the full material set in there. And I'm looking at the borders again, and I wasn't really liking how some of the edges were, again, kind of blending in to make these like weird looking shapes that don't look like concrete. So what you can do actually here is use something called the Mutation Revision. And what this is going to allow you to do is use a gizmo in the window and selectively kind of like heal sections. So that crack didn't look natural to me, so I just put my box over it and hit the execute on region, and that actually computed something that looked a lot more natural. So this one looks a little bit odd, so I'm going to execute on region, and it's going to kind of fill that in with just plain concrete. So, you know, a normal workflow, you would probably use like a typical clone stamp here and clone the cracks around. But what I'm using here is kind of like a smart selection tool to kind of just fix some of these areas up. So you can be as picky as you really want with this. I'm just trying to look for some odd shapes and just revising them essentially, and kind of hoping that the AI does something in a way that it's going to look natural. So that one didn't really work, and it just added more concrete there. But when I kind of go on the other side, the tiled part of it along the seam, and I execute again, it actually put a pretty cool looking crack over there. So that was pretty rad. So I was looking around the material here, so I didn't really like how these things were fusing together. So this is definitely a common problem that you're going to run into when you're working with more structured elements, is just the AI is going to start to, like, when it pieces things back together, you're going to get these kind of like merging of shapes. But this is where the feature ghosting and the mutation comes into hand, using the mutation revision as well too. So I'm just going to scan the material again. And I think I'm just going to leave it for the time being. And instead what I'm going to do now is fix up some of those projection errors that I first mentioned earlier in the video. So this stuff is all stretched over here. And all I'm doing here is I'm going to use the mask paint into a content aware fill. And you'll notice that on the content aware fill that I have also the structure guide placed into that. And what that's going to do, it's going to take the areas that I painted, do a content aware fill, but also maintain the structural element that we provide to it. So there's kind of like a lot going on here. These ones are a lot more complex to tidy up. So I'm just kind of going in here and kind of painting some of this. So what's going to happen here is when I do this content aware fill pass, it still is going to sometimes make kind of like an odd shape out of it. But that's where the structure guide is going to kind of protect some of those areas for you. It's not always going to be foolproof, but in this case, it actually worked quite well. The thing that I can really suggest is just take a better capture set from the beginning, from the get-go, so you don't have to do this pass. But again, we didn't have the most ideal data set to work with, so we're just kind of doing what we can here to salvage it into a proper and usable material. So we're just going to let that content aware fill process. And every time I let these things process, sometimes it takes quite a bit of time, especially if you're using, working at 4K here. Depending on your GPU power, it's going to take quite some time. So I always try to build out my graph as I execute these. So just checking out the maps. So I'm kind of looking at the before and after. So this area was missing a lot of data. So I'm just pressing I and O on the keyboard to see the input and output. So that's before and after. Zooming in a bit. So you'll see some of that missing data gets filled in quite nicely with the content aware fill. You'll see that area actually made like an extra crack area. I wasn't too happy with that, but again, it filled in naturally. I think that's the point of it. And I'm just checking it out on the 3D viewport. So, I can't really say that it's like 100% perfect. And what I mean by that is there's still some cracks that don't really look super duper natural, but it's getting it's pretty close, close enough for my liking. And again, when you put this in context of the environment that you're working with, you're going to probably put decals on it. You're going to put a lot of mixes on there, things like water, oil stains and things, and hopefully you'll kind of miss some of that. But in any case, so what I'm going to do next is work on the color map. So I'm using the color match again, and what I usually like to do is bring in a scanned data set that's calibrated. So again, I'm just using a Quixel Megascan of concrete, and I'm going to color match the two. So taking my source data, color matching it to the Megascan data, and that thing just works. I love using the color match. It's super duper handy. This saves a lot of time from having to eyeball things by hand to get the right colors to fit in with other materials living in the same biome. So I'm also going to use the reference transfer. So again, this is the Megascan roughness map, and I'm actually going to match the two as well. And again, with roughness maps, it's always good to take a little bit more time to kind of fine tune them, but for the video, just for the sake of time, I'm just going to do a quick color match, a roughness transfer to get my base roughness map. And just throwing everything into the composed material for the output. And I noticed that it's starting to look a little bit weird, but that's because I actually accidentally put my height map into the metalness map. So I'm just taking a look at it. You can see that the height is wired incorrectly. I'm just gonna detach that, and I notice that it's still happening. So what I end up doing here is just deleting the metalness completely out of the composed material. So I'm just checking the maps to see what's wrong. It looked like I kept the height data in the cache, so I'm just gonna remove that, and then we'll take a look at it again. So, I mean, we're almost done here, but I'm looking at that one area where, you know, there's like 4 plates of cracked asphalt kind of merging together. So I'm just going to do another final pass of content aware fill. So just honing in on that area, bringing out the content aware fill. And this time I'm going to do the mask paint on the area that I want kind of like recomputed. But this time I'm not going to use a structure guide. I'm just going to let it do its thing and see what happens. And I'm just checking the 3D viewport, seeing where things are fused. So there's another one over there. And sometimes it's a little bit difficult to see kind of like where you're painting. The brush does show up on the 3D window. You can't actually paint on the 3D window, but I'm just trying to use it here as reference to find out where that spot is exactly. So I'm just going to paint in that area. And just kind of scanning it over again. And you can do this, like you can spend hours doing this depending on how picky you want to be. So I'm just going to paint that in and let that compute. So the cool thing about the content aware fill is that you can execute it, let it do its thing. If you're not happy with it, there's also a new seed, kind of like the seam removal and mutation. So if you're not happy with it, just hit the new seed a few times, re-execute, and it'll just regenerate a new version of the content aware fill. In this case, I didn't do the new seed. It actually filled it in well enough that I was happy to export my material with. But in the case that it's not really filling in with the right material, you want to generate a new seed. So that actually filled it in with a nice crack, so that was pretty cool. And I'm just checking in like one more little small area. So if you watch any of my other videos inside of ArtEngine, you'll see me using the ignore mask and the seam removal to actually like fill spots in. I typically don't really use the content aware fill because what I found using the content aware fill, if you have bad data like laying around your material and you do a content aware fill, there's a chance that the area that you painted in is actually going to fill it in with bad data. So really the workflow that you want to kind of go through with the content aware fill is ensure that everything's pretty cleaned up before you start using it. Otherwise, you're going to run into the risk of it pulling something in there that you don't want where you painted in. So this is kind of why I did this final pass at the very end of the cleaned up material. And we're going to let that compute just one more time. So, I mean, all in all, yeah, this took about 28 minutes in real time, which was not too bad. I felt like there was kind of like a lot of just mass painting. And again, it really depends on how your initial capture was going to be. I always suggest that you do your best to capture things to give the software the best chance to succeed. But I always know that's not always possible, especially if you're learning how to do photogrammetry. It's something that I'm still trying to pick up and hone in my capture process. So I'm actually going to tidy up my graph a little bit here before I end the video. So I'm just going to add some frames around sections that make sense. It's always a good thing to do. That way, if you kind of come back to these graphs, you have something a little bit more organized than like a mess of wires that, you know, typically will happen when you're in production. So just adding some labels to some of these areas here. Okay, so I've got all the maps exported out to good old Marmoset Toolbag. So it's checking out the scene with some lighting in here. And we're just going to turn off the albedo and just evaluate the surface with just the height and normals. So just kind of having a look at it, you'll notice that you know, there's some areas over here that were still lacking some details. So I could have went in there again and kind of content aware filled it just a bit more to clean it up. But that's definitely for, you know, like another video, or just to spend more time working the material a bit more. So I'm just going to check this thing out again one more time. Cool. So, you know, if you're curious about using ArtEngine or learning more about it, I do have a full playlist of basically all the nodes that I kind of went through today, and things like mass paint, mutation, mutation with mutation structure, it's kind of like how to navigate the UI and stuff like that. So, you know, what we did today was we did a full photogrammetry scan. Don't be scared that you have to get like a nice camera and kind of do this stuff. If you kind of visit my ArtStation here, I also have a lot of other ArtEngine work that I've done. So some of these scans that I've done over here are just with my old iPhone with about 20-30 photos. I'm using 3D Zephyr, the free version. So that one takes maximum 50 images. But these are all pushed through ArtEngine through the same process to do the seam removal and generating the full material. I hope this video shows off a little bit more about what ArtEngine is and what it's capable of doing. If you made it to the end of this video, thanks so much for watching. Till next time.